concept 3, number 5, it asks you to sketch force diagrams for 3 different situations, as well as write equations for the sum of forces in the x and y directions. So for the first system, you have an Atwood's lab, and it tells you that it's accelerating and that there's friction because it says that the coefficient of kinetic friction is greater than 0. So you draw your force diagram, and it's not accelerating up or down since the block isn't leaving the ground. So you know that the forces in this direction have to be balanced. So you're going to have force gravity from the earth on the object, as well as force normal from the surface on the object, and they have to be balanced because it's not accelerating up or down. However, it is accelerating left and right, so you know that your force tension from the string pulling on the block has to be bigger than the force of friction, which is opposing its motion. Because these aren't balanced, the block is accelerating. So then writing our equations, we have force normal equals force gravity, so this is the components in the y direction, and in the x direction we have force tension is greater than force friction, which allows it to accelerate. And then moving on, we have a block on a ramp, and the ramp is at an angle, so we're going to draw our force diagram at an angle. Gravity, it's not accelerating up or down, it's actually motionless, so that means all your forces need to be balanced. So you're going to have gravity still going down, and you're going to break it up into its x and y components. So this is your force gravity in the x, and this is force gravity in the y. And then you know it's a 15-degree angle because of the diagram. And then you're going to, in order to oppose this force gravity in the x, since you need to have a force equal and opposite in order to balance it out, you can assume that there's friction in the opposite direction. And then in order to balance out this force gravity in the y, you know that there's force normal. So then when you're looking at your equations for your motion in the y direction, you have force gravity in the y equals force normal. And then in the x direction, you have force gravity in the x direction equals force friction. So all your forces are balanced in order for the block to be motionless. And then last one, you have a block with tension pulling at an angle of 20 degrees. So the block is still on a flat surface, you have a normal force diagram. And then you have tension of 200 newtons at 20 degrees. You need to break that up into its y and x components. This is force tension in the y, and this is force tension in the x. And then it says the coefficient of kinetic friction is 0, so there's no friction, so there's no motion to oppose this force tension in the x. And then there's force gravity acting on the object from the earth, and since it's on a surface, you can also assume that there's force normal. And since it's not moving up or down, you know that force normal and force tension have to be equal to force gravity. So both these forces together need to equal force gravity, so force normal plus force tension in the y equals force gravity. And then there's nothing to oppose the force tension in the x.